So let us talk about various terms which are used in 3D graphics, and let us start with aliasing, and we will go by alphabetical order. What is aliasing? These are undesirable rendering artifacts in the form of jagged lines like this, or edges or surfaces in computer images. These are, you can term them undesirable rendering artifacts as aliasing. Then alpha channel. What is alpha channel? A channel of data in bitmap images which stores the transparency of the image, generally used for compositing. Means you might have seen these terms RGB, right? Now, what if we want some sort of transparency or non-transparency? For that, you just have to add this A, RGB A. This A is the alpha channel, specifically for bitmap images, and this increases, or this allows the transparency that can be done. And this 32-bit image has 24-bit of color information, and they have 8 bits of alpha. Alpha means transparency possibility. So this allows actually 256 levels of transparency, from totally transparent to absolute opaque. And for example, if I may give an example, if you have certain images, one image on another image, and if you want to see the image which is on the background, so what you can do, you can set this alpha transparency so that while viewing the image which is on the above, you can also see the image which is on the back side, which generally, if you employ without alpha channel, will be not seen. Then ambient color, the color of surface where it is not directly illuminated. Please understand, the color of the surface where it is not directly illuminated it is influenced by the brightness and color of ambient light. Now, if you have an object, right, this is an object, and if this is illuminated with certain light source, then the color of this area which is not directly being illuminated is called the ambient color. And as I indicated earlier, it is influenced by the brightness and color of the ambient light. Then ambient light, general lighting that illuminates the scene, often without respect to this direction. This is just a general light that illuminates the scene. So it attempts to emulate the effect of light bouncing off all objects to illuminate all other objects, but it is not a true simulation such as radiosity. We'll talk about radiosity also. And a high ambient light setting results in a washed out scene, since no shadow can be darker than the ambient light. Then anti-aliasing, as we saw that aliasing are generally rendering artifacts. So anti-aliasing is an algorithm which attempts to correct this jagged, aliased computer image, these artifacts. So blurring the image is maybe the one of the method. There are various methods for anti-aliasing. A more advanced method is also super sampling. And coming to aspect ratio, this is very important. You might have seen not only in 3D graphics, but in your mobile, in your display devices. Always there is, or in the images also, aspect ratio. Even if you go to PPT, there will be an option of setting the aspect ratio. So the portion of this aspect, that is the proportion of screen width. If this is the screen, then the screen width to the height, the ratio is aspect ratio. So for example, NTSC video has an aspect ratio of 4:3. That is 1.33. It's dimensionless. And other common aspect ratios are 16:9. Now we have displays which are not perfect square. They are rectangular in shape, like you see in movie hall, picture hall, for high definition video. And this is 1.85 for widescreen, theatrical, 35 mm film. So the number of pixels in an image is independent of the aspect ratio. This is very important. this pixel has no dependency with this aspect ratio and need not even be a whole number multiplier of the aspect ratio. Fine. Then coming to attribute, the property of any 3D object that can be adjusted. These are the property. Attribute means property. So attributes are sometimes called the parameters. Attribute, properties, parameters, all they are used, some in same terms, and they are usually animatable. So attributes are found within nodes. An example of these attributes include the radius of a sphere, its position in this x and y and z axis. Now coming to our basic spline, that is our B-spline. B stands for basis spline. This is a smooth curve which is controlled by 3 or more control vertices. So this is a curve, you have 3 vertices, right? And this particular B-spline is a curve, very smooth curve, but this is controlled by 3 vertices. So the B-spline always intersect the first and last this control vertices, but is usually not influenced by the others, right? This is B-spline. Bezier, this type of spline or patch that uses adjustable tangent handles to control the curvature near each control vertex, right? This is named after Pierre Bezier, an engineer at the Renault Auto Company in the 1960s. So Bezier patented this technique based on earlier work by this gentleman Paul. So again, let me reiterate it. This is a type of spline that uses adjustable tangent handles, right? You know tangent? This is the tangent. So it uses this adjustable tangent handles to control the curvature near each control vertex, right? If this is a control vertex, say this is a control vertex, say this is a control vertex. So it uses the adjustable tangent handles like this, right? So in bitmap, it's a still image produced by fixed matrix of pixels, for example BMP, Microsoft bitmap, GIF, computer graphic interchange format, JPEG, joint photographers, photographic expert group, TIFF, tagged image file format, TGA, True Vision Targa, and PNG, portable network graphics. So these are all bitmaps, and they are still image which are produced by fixed matrix of pixels. Then Cartesian coordinate system, a method of locating points in 2D or 3D space by measuring distance parallel to intersecting straight line axis, like this. If this is XY, so you can have a point in 2D, you can have a in 3D. This is X, this is Y, this is Z. So this point can be located via Cartesian coordinate systems. So these coordinate axes are perpendicular to one another, defining a 2-grid or 3D cubic lattice. And this was first published by French philosopher and mathematician René Descartes in 17th century, back ago. Then compositing, the combination of 2 or more images to create a new image. You have various images, you can combine them, and that process is called compositing. So a simple example would be foreground character superimposed over an environmental background, right? This is simple compositing. Then diffuse color. What is a diffuse color? A color of a rough or matte finish surface. So if you have a rough surface, the color of it is termed as diffuse color. In dynamics, automated or semi-automated procedural animation that simulates how objects move in the real world, typically employing our laws of physics, Newtonian physics. So this is dynamics. So rigid body dynamics describe how objects respond to, say, gravity and collisions. So soft body dynamics, they additionally simulate how objects deform and motion. These are all, they all come under dynamics. The edge, the boundary between two faces of a mesh model. The boundary between two faces of the mesh model. If this is a mesh model, say I draw a face here. This may be a triangle face, and this again may be a triangle face. So the boundary between these two faces of a mesh model is an edge. This is an edge. Okay, and the edge is a straight line connecting two vertices. There may be any two vertices and bounded by a face of either side. A face of either side. Then effects animation, broadly speaking, any animation which involves special visual effects rather than character animation, or simple transform animation. These are effects animation. It does not involve visual, character animation. So examples are particle systems and dynamics. Then expression, relatively simple statement in mathematical or computer programming languages, which is used to generate or manipulate data for animation. These are simple expression as we have learned in our mathematics. For example, a particle system which tend to rely on expressions to control the generation behavior of the systems. You have certain expression and it follows it. An expression usually takes the form of an equation to set the value of parameters or attributes like y is equal to mx plus c. Okay. Now in this you have c and m, and how this y and x are dependent? They are dependent with the value of m and c. Then extrude. Extrude means a simple process of converting this 2D shape into 3D. Extruding. A copy of 2D shape is moved perpendicular to the original, like this, and then connected to the original to create a closed surface like this. If say this is a 2D shape, this is moved perpendicular to the original, means say it is moving like this. All these 3 points moving like this, and you create a closed surface. Now this is 3D. This is how we made a 3D out of a 2D. For example, extrusion can be used to create a renderable 3D logos from say 2D text shapes. This is extruding. And the face, the renderable 2D plane. The narrowest definition of a face is a triangle, that the simplest possible 2D shape. A face can also be a synonym of a polygon. Okay. For example, let me take a cube. This is one face. See, all these are faces. 1, 2, 3, 4, 6 faces are all. So all these are renderable 2D plane of a 3D, or not even if you don't talk about a 3D also. This is by itself a plane or a face. Face normal, also known as a polygon normal or surface normal. This is a visual indication of which side of a face is renderable. It is displayed as a line pointing out perpendicular to the surface of a face. For a one-sided surface, it is normal is pointed away from the camera. That face will not be rendered. Okay, let me show you. If this is an example, let me draw it. I'm not very good at drawing, so pardon for it. Now these are the faces. Now I want to render from here. So the perpendicular which is coming out of this face is the face normal. So which is the perpendicular which is going this side. So this face will not be renderable. Okay, this face will not be renderable. The fields, interlaced subframes in a video frame. Interlaced subframes in a video frame. These are fields. So there are 2 fields in each video frame. Field 1 is composed of all odd numbered scan lines, and field 2 is composed of all even numbered scan lines. So rendering fields improves the smoothness of fast moving objects by viewing on interlaced video frames. So this is interlaced subframes in a video frame. Then flat shading, a rendering method which does not smooth any edges among faces, resulting in a faceted look. This is also known as constant shading. Let me show you again that, or let me tell you again. This is a rendering method which actually does not smooth any edges among faces. So there are many faces of a 3D, So this is a method which does not smooth any edges, right? It leaves the edges. That is why we have a flat shading. Then coming to frame buffer, the portion of a computer or a peripheral memory that store an image so it can be displayed or recorded on another medium such as analog film. Now if this is your display device, okay. Now when a system sends information, this comes from your frame buffer. So this is the final place where it is kept to be displayed. All rendering, all processing will be done in the background. Once it is ready to be shown, it will come in the frame buffer. So this holding area is the frame buffer. Now fractal, a mathematical object that exists between dimensions, right? You might have heard about dimensions. This is an object that exists between dimensions. The most famous fractal, the Mandelbrot set, can be represented as a flat image. However, this boundary has infinite details, so it is possible to zoom infinitely deep into the image. For this, it is considered to be a 2.5D object. So, an object like this that exists between the dimensions. 2D and 3D to 2.5D is fractal. Fractal algorithms are widely used in computer graphics to simulate complex patterns such as those found in natural phenomena. For example, realistic mountains that can be generated using fractals values mapped to elevation, and simulated clouds or other volumetric effects that are commonly generated with fractal algorithms. And these algorithms are actually iterative, meaning they can be calculated repeatedly to achieve higher level of detail. Then coming to function curve, this is a two-dimensional graphic representation of animation data, right? 2D graphic representation, because you want to animate the data, so you have to have a 2D graphic representation. So the value of a single parameter or attribute is displayed in the vertical dimension of the graph, and the time is displayed in the horizontal dimension. So these dimensions, two dimension, one is for time and the other is for the attribute. So the slope of the graph indicates the rate of change of the parameter, the attribute, and the steep curve indicate fast change or motion. Shallow curves like this, they indicate slow change, and flat horizontal lines indicate no change. So they are also termed as F-curve sometimes. Then coming to gamma, the constant curve of recorded image. The constant curve of recorded image, so increase the gamma of an image makes it appear brighter, that is more washed out, and decrease the gamma will see it as more darker, that is muddier. The gamma correction is applied at many stages of image creation process, most profoundly to display on your display devices. Then coming to global illumination, a rendering algorithm that attempts to simulate the transfer of light among surfaces in a simulated environment. This is global illumination. Why it is called global? Because compared to the local illumination, in which there is no calculation of bound slice, reflection or refractions, global illumination says that okay, this is the light, there are various objects, how it will bounce off, how it will be diffracted, or various physics law will be applied. This is global illuminations. Then coming to HDRI. HDRI is high dynamic range imaging. This HDRI provides a more realistic simulation of lighting than the previous techniques of this field. So it stores much wider range of values to describe the brightness of the pixel, and standard bitmap images can typically reproduce a contrast ratios of about 1000 to 1. So this HDR images can reproduce the full range of real world light intensity for contrast ratio in the range of 1,00,000:1. Hierarchy, the structure of linkage among objects necessary for animation of system with moving parts such as characters and vehicles. This is also known as parenting, linking, and forward kinematics hierarchy. So it is a standard animation hierarchy. In that particular case, child objects inherit this transform information from their parents. So an object may have many children but can have only one parent, right? Like this. This may be an example of a hierarchy. Then interlaced scan, a video display mode which uses alternating field to create the image, right? For each video frame, odd numbered scan lines are drawn, followed by the even numbered scan lines, not at once. So NTSC video is interlaced, so most computer monitors, they are not. Interpolation, calculation of various values between known values, means if there are two values and only these values are known, if you want to find the intermediate value, this is interpolation. For example, a smooth curve can be described using just a few control vertices. Inverse kinematics, an intuitive alternative to standard hierarchical animation. An intuitive alternative to our standard hierarchical animation, because the position and orientation of these parent objects are calculated from the position of the last child or end effector. So the final position of the hierarchy is called this IK solution. Keyframe. Keyframe in computer animation, a user-defined value for a parameter at certain point in a time. So the parameter which is user-defined at certain point of time is the keyframe. The animation sets keyframe at significant moments, and the software or the computer software fills it all in between values using some. We have already seen interpolation. This is interpolation is used. Now, map. In 3D graphics, a map is an image used within a material. The purpose of map is to vary some material attribute across the surface. For example, a texture map alters the color of an object, and a bump map simulates the roughness. And the 2D maps, they include all bitmaps requiring mapping coordinates, which tells the renderer how to project the map onto the 3D object. And also 3D procedural textures do not require mapping coordinates because they are volumetric. Material, the surface property of an object such as color, reflectivity and opacity, they come under material, and they are also known as shaders sometimes. Mesh, a 3D object which is composed of triangular faces. A mesh object has no true curvature, right? So the appearance of curvature is achieved by the increasing the number of faces, that is the LOD, level of tail, and by edge smoothing during the render time. So this is a mesh. Okay, this is a mesh. You have triangular faces, composed of triangular faces. So this was the first part of 3D graphic glossary or